Hi, everyone. A very warm welcome to all the participants. We are excited to have you here. I'm sure that this webinar will present an opportunity for all of us to learn more about real world 5G use cases. I'm Aakanksha Gupta. I'm part of business development team at Amantya. I welcome you all to this exciting session on exploring real world 5G use cases with Amantya's 5G lab solutions. I'll be moderating this webinar today. So I'll be recording this session and the recorded video will be sent to all the participants. Again, I will take a moment to introduce our speakers today. We have Gaurav Sharma, who heads the engineering and oversees all the 5G services at Amantya. And we are also joined by Gaurav Saini, who oversees and heads the business development, pre-sales, and customer relationship management at Amantya. So without taking much time, I'll jump to the agenda of the session today. Gaurav Saini will be going to initiate this session by giving us a brief introduction of 5G labs and its importance, some real world 5G use cases, and a brief about Amantya's 5G lab. While Gaurav Sharma will be taking forward from there and explain in depth about enabling a 5G lab and also give us a brief demonstration. If any questions strike your minds, I would request you to please type them into the Q&A section and we will take them at the end of the session. So, without any further delay, I will now hand over the floor to Gaurav Saini.
Thanks, Akanksha. Thanks for the introduction and inviting us for this webinar. Uh, Today, we are hearing a lot about 5G, but we know there are a lot of various organization which already have some kind of network infrastructure, be it Wi-Fi or 4G. Then why are we talking about upgrading them to 5G? 5G brings a lot of new feature set, be it gigabit throughput, low latency networks up to 1 millisecond, or thousands of devices connected over 5G network as MMTC, massive mobile communication network. Today we know the existing Wi-Fi and 4G is not able to provide low latency network and then high throughput. That's where 5G comes in. But from a current scenario, moving towards the exact actual 5G deployment, various organizations have to go through various steps, various test procedures in their environment. That's where Amantya helps organization to set up 5G lab in for their POC for specific use cases. Setting up a 5G lab will help explore different 5G benefits specific to an organization, industries, MNOs, then help them foster R&D initiatives, develop specific prototypes which would help them for their use case, and then test all the use cases. That would help them to totally understand how 5G will be able to benefit them in the actual deployment. This helps them in error-free deployment, definitely help them in a lot of cost saving, and then make them understand in terms of various use case deployments and enabling automation, which is a key pillar in terms of improving a productivity, enabling industry 4.0 system. When we talk about 5G use cases, there are various industries, various use cases. Manufacturing uh, is a biggest use case which has been deployed. When we talk about manufacturing, industry 4.0 use case implementation using AGVs, AMRs, then deploying a 5G enabled video surveillance system, be it a 4K camera or AI enabled remote video analytics, which helps in worker safety or even security. Education, 5G is going to be a key support in terms of giving an immersive learning through AR, VR. Everybody knows that there has recently been a study that only students retain only 10% of the content what they read about. However, if they do it through immersive learning, maybe AR, VR, they are able to retain up to 90%. And that's where we need to go. In terms of online classes, everybody has gone through the COVID. Uh, Everybody has seen what COVID gone through the COVID, and complete the have to go through all the online classes. That's where high throughput network plays a critical role, and 5G is enabling that. And then moving towards venues, uh, we know FIFA World Cup is going on, and then Qatar, all the stadiums are already 5G enabled. Using 5G, they are enabling AR VR experiences. Then enhanced event viewing is enabled by 5G at the entire FIFA stadiums. This definitely also helps in monitoring and the security of the entire facility, end to end enabling use cases. And then moving towards smart farming, we know that increasing productivity is the biggest challenge which humanity is going to face in the next decade. That's where 5G is trying to help farmers, agriculture industry to increase productivity, be it with the smart 5G sensors for soil moisture content, and then again targeted inspection of the farm fields using drones, be it targeted spray of pesticides, fertilizers, or removal of targeted weed, which helps farmers to reduce the cost and increase productivity. Logistic is another use case where AGVs, AMRs, self-controlled autonomous vehicles, and then delivery through drones, either in indoors warehouse or even outdoor, maybe through FedEx, Amazons, and then through a public 5G network, fleet tracking could be done. Moving towards MNOs, our beloved mobile network operators, we all love when we see a high throughput gigabit on our phones. 5G would do that. However, we do work with MNOs when they have to do a various interoperability testing. They can use our product line to test one RAN with multiple core network solutions, or they can use our core with a different third-party RAN ecosystem testing. How Amantya helps in? So we have designed a network in a box solution. It is an integrated 5G out of a box solution, which comes with a 5G SA core and RAN solution. So this is completely out of a box plug and play. This has only two ports at the back. One is a power port and one is a gigabit Ethernet port for backhaul, only if needed. So you power up the system, you do a basic configuration, something we used to do in access points, and then voila, you have a 5G network up and running. We understand that spectrum is a major issue globally. Each country has different requirements, each customer may have different spectrum. So we have designed this network in a box in a completely flexible, supporting entire sub 6 or FR1 band. You can configure any FR1 sub 6 band and have your 5G network up and running. This also includes a management interface. So out of a box, you have a full-fledged 5G network. And this is where we propose that anybody can use a network in a box solution and set up their lab. This is around 4.5 kgs, so it's highly portable. In terms of a 5G starter kit, we start with a 5G network in a box. Then we bundled it with 5G SA modems, SIM cards. We also bundle in a Raspberry based hardware for application development. We also can bundle in a IoT gateway, which could help integration to legacy IoT sensors, be it NB-IoT, LoRa, Wi-Fi, Zigbee. We can also bundle in sample Bluetooth, Wi-Fi, and other sensors. We also help our partners, customers to develop specific applications for their specific needs. If it's a manufacturing, maybe an integration over PLC SCADA. If it's an education, then maybe integration to AR, VR, or smart classrooms. You name it. We have been doing the development in terms of completing the 5G ecosystem for our customers. So when we talk about 5G lab deployments, there is a standard deployment where you take a NIB, connect it with different use cases in a lab, and you can do all your testing in-house. However, everybody knows that 5G brings in a lot of edge computed functionalities to use this next generation feature set of ultra low latency up to 1 millisecond. Then again, in terms of high throughput, a lot of Mac sites are being deployed. Recently, a report said that 25 million potential MEC sites have been identified for deployment, and Mac platform plays a critical role in delivering the feature set. That's where, because our NIAB has a UPF bundled in, we have already integrated our network in a box to our existing Mac platforms. So in terms of a testing, we start with a standalone deployment, and then we can integrate your lab to a Mac platforms to enable the newer functionalities. I'll take this opportunity to hand over the floor to Gaurav Sharma, who can take us forward in this discussion.
Thanks, Gaurav. And a very good evening, good morning, good afternoon to all the participants here. Before I start talking about some of these end-to-end flows, let me first establish some of the uh, reasons why we feel that this product is extremely important and why quite early in our organization we started focusing on building of NIAB. For any new technology to be adopted widely, it is very important that there is this sense of ease of deployment of that product. And there's an ecosystem built which allows devices or products around this technology to be built easily, right? Now, with a complicated technologies such as 5G, it's extremely important that uh, to make this technology successful, there is a framework or an ecosystem through which applications can be easily built and, more importantly, easily tested, uh, so that organizations, enterprises, they can come up with innovative solutions on 5G. Now, one of the challenges that a lot of organizations or individuals face, and especially when we talk about such complicated technologies that require huge infrastructure, is how do they test their applications, right? So there is this big gap between the deployment and the development environments, right? I may be sitting in my office, I may be developing a or what I think may be a killer application for 5G, but then when I run this application in an actual 5G network, it may behave in a completely different manner, right? So there is this big gap between these two, and it is extremely important to fill in this gap. Now, this was exactly the reason why we thought that probably it would make perfect sense to for us to bridge this gap. And again, the reasons here being that since we started investing in 5G around 4 or 5 years back, we were building products around 5G. This gap was quite in front of us, and we could ourselves see that for this technology to be widely adoptable, we need to come up with solutions around this space, right? So that is where we started investing into this whole idea that how do we take out the complexity of the 5G world for a out of the whole development cycle for a end user or a end application developer or enterprises, and let them focus on building the business logic or the application logic that they are out to do, right? Because you don't expect uh, developers to be 5G experts, right? And at the same point of time, you would not want them to invest a lot on the infrastructure as well, right? 5G is all about enabling end users, enabling application developers to come up with innovative technology, right? And if this is what this product offers, then we think we have a winner on our hand, right? Now, I'll talk a little bit about uh, the end-to-end flow on how use cases typically get implemented, right? And then I'll talk how does this map onto our NIAB and the lab view that we have, which uses the NIAB. All right. Now, like any product development, we've broken this into certain steps or certain phases, as you can already see. on your screens. The first aspect is, of course, the use case planning. Now, this is the stage where the developers or organizations actually narrow down on the requirements and then plan on how do they want to implement these requirements. This is typically a requirement phase, freezing phase, where parties or stakeholders get together and commit the resources. The next step, obviously, is the actual implementation phase where the software developers, testers, they would get together to develop the logic and test the logic in a limited environment using emulators, etc. Once this is done, then you get into a phase where you actually want to integrate your product, your devices, your applications with the say the 5G networks or other components which are behind the 5G network, and retest certain things, right? So that's the next step. So you've uh, deployed your application in the 5G network, you've deployed these application servers as well, and now you've started your final legs of testing and validation. All this is followed by the final test results or the test reports. What these test reports would actually confirm is that if your solution conforms to the requirements or is in line with the planning that you had done, which also means that it also is in line with all the functional, non-functional requirements that you had written in the first phase. So this is a simple phased approach that is applicable for a lot of applications, right? Now, the critical aspect here from a 5G use case perspective are the last three steps: use case integration, use case testing and validation, and then use case test results. Now, this is where the 5G lab becomes extremely important, and this is where uh, people can leverage Amantya's solution to actually build 5G applications, 5G devices, IoT sensors, etc., etc. Right? I'll go to the next slide. Right. So let me just walk you through the different, very simple steps to set up a 5G lab. Right. And it's a very simple, uncomplicated procedure, helped by, of course, the product that we have. Right. Now, the network in the box, or the 5G NIAB, what we call, that already has all the required 5G core components in it. So the radio part, the core signaling part, the user plane data functionality, everything is uh, within this particular box, which means that organizations don't need to run here and there, get into expensive logistics or other steps to come up with a 5G network within their lab, right? So this is a plug and play, very simple box. Uh, the configurations are pretty much simple, right? And of course, we do pre-configure these boxes as well, right? So that's piece one. The other piece that you see are the starter devices. Now, what these starter devices actually do is that they already give you a framework or a platform where and you can just go write your application, which means that you'll only be focusing on your business logic and not worrying about the 5G signaling or how my data is getting transmitted, or how even the application that I am writing, right, that actually communicates to, say, some of the internal hardware of the device itself, right? So all these complexities are abstracted out by these two offerings that we have. So to begin this story, you just have an empty lab, you put in these two pieces, and after that, it's up to the developers and the stakeholders to actually come up with the use case definition and planning, which I spoke about earlier, right? So here, the user is actually not worried about, oh, how I would be getting this 5G connectivity, what spectrum, will the messages be reaching my core, oh, is there a valid connectivity with the UPF, right? So those are things internal to the box. The user here or the developer here thinks about his or her application. Okay, that what is that I want to write right now. Here in the picture, of course, you have two people. One wants to do something on smart agriculture, while the other one is thinking about, okay, if I have a industry, right, how do I leverage or how do I come up with smart applications, right? So once the use cases are defined, the planning is done, right, you just go ahead and start implementing the use case, right? I'll Now, for this, you may, of course, require to procure some of these sensors or some of these components. Of course, some of these things are already part of our device starter kit. But in case if there is something very specific that you need, we have a very extensible design, and any external sensors or third-party hardware that can be easily plugged into our starter kits using some of the standard interfaces that we offer. Right. Now, from an implementation perspective, again, there is a SDK, which is part of our solution where the actual application programmers, they can go ahead, they can implement the logic, they can then start testing this through our 5G network and through the to the application servers that have been deployed. I'll take a very practical example as well, right? So that it'll help you understand some of these things, right? So say tomorrow I want to uh, build a IoT sensor that say measures the water level of a tank, right? And I want this to work on 5G technology. Right now, of course, if you look at it from an end-to-end scenario, it's a very complicated thing. You have IoT sensors, you have a 5G network, a radio in between, then you have 5G components, you have user plane functionality, and then you have an application server, right? Now it's practically impossible for an application developer to actually think and build all these components individually. Now, with this particular solution, the application developer will only be thinking about the way the IoT sensor is going to read the water level and what is the message that he or she wants to send to the application programmer uh, over 5G, right? Now, there are sample applications and examples that we provide through our SDK, through which any developer can utilize some of the base libraries that we provide to communicate with application servers. Again, these can be based on REST frameworks, MQTT, WebSockets, binary data, and so on, right? Now, the application developer is here is only worried that, okay, I read the values from my IoT sensor, call some of these APIs that the NIAB solution provides, the framework provides, and send it to my application framework, right? The application framework running on the application server, as you can see, will ingest these values. And based on some analytics or whatever the end logic is to actually display it on the graph, store it, maybe generate certain alerts, right? So that is pure in the application sphere. And that is what the application developer would be thinking and focusing on. So once he has developed this particular application and the application um, backend, right, he can just go ahead and start testing this on the NIAB or through this NIAB. Now, if you look at in this particular picture, there's a very important key piece, which is MEC. Now, as I mentioned earlier, 5G is all about bringing to life new applications, right? It's again one of those things where these networks are being used to actually build applications for end users, right? Now, MEC is again a 5G component and which can actually be used to build a number of innovative newer applications. So what we have done is, since we believe that MEC is going to play a very critical role in building new applications and making this whole 5G concept successful, we've already integrated our NIAB with a MEC implementation, right? What this also means is that the application users, they can now not only build simple applications, they can build applications that require mech as well, right? So this is a distinct advantage with this particular product. So you can come up with applications that are quite latency sensitive, that require fast processing and speeds. Right. Let me go to the next slide. Yeah. So once you've started uh, testing your particular application, you'll have the results. You can check the results. You can see some of the messaging protocols used. You can validate your product, fix the product, and then you are good to go and start your trials in a real world or in a real live network, right? Of course, once you have these results with you, you can actually start comparing this with uh, your initial plans. What were the different functional, non-functional KPIs, metrics, etc., that you wanted to measure or you wanted to validate. So those are things that you can do very easily with this whole setup, right? And of course, this also provides you a platform or a framework where you can now start thinking about the next steps in terms of enhancing your application, planning for the next deployment steps, uh, also trying to create certain specific environments to test your applications in other scenarios as well. Uh, Now, let me talk about some of the applications, right? Since we have spoken a lot about these applications, right? I'll just touch upon briefly on some of these applications that can be built. And of course, this is not a complete list, but you can think of it as, of course, robotics is again a very interesting 5G use case. You can think about robotics applications, drone applications, video analytics, connected car, and here mech uh, can play a very critical role. AI/ML solutions, right? And then the whole idea here is that the end user or the application developer actually, he or she is focusing, concentrating on the application itself. So what this also means is that now you have opened up this whole field to a number of application developers, right? Which means that, of course, this is going to enhance uh, both the quality of the telecom applications or the IoT applications, devices, sensors, etc., and even the number of applications that can be developed. Of course, and since we have had some history in developing some of these applications, both on the device side as well as on the cloud side, uh, we are kind of the perfect partner to actually help uh, in building some of the 5G applications. Now, moving forward, probably I'll pause here. I'll go through the video that actually talks about how simple this whole process is. It'll give you a real feel on this. So just give me a minute. Right. So there are two simple cables that go as an input into this particular box. One is, of course, the power cable, and the other is the Ethernet cable. Now, this Ethernet cable is the one that would be connecting to the application server, right? There's a simple power on step. You just go ahead, power on the device, and log on to the device, and you get this particular page that actually helps you see the status of the box and provision in case if you need to provision a device, provision a new SIM, etc. Here you can actually just go ahead and uh, uh, check the status of the 5G network that you have. You can provision subscribers. If you have uh, added new devices, you can configure them. You have a traffic analyzer, right? You can select this operation mode as well, wherein say you want the 5G core to be part of this particular uh, box itself. You can do that. Now, this is your uh, device here. We've taken a sample 5G device here, and this particular device has latched onto the NIAB box. And what you can actually see is you can just go ahead, look at the available networks. So here, Amantya Test 5G is our 5G network. This is radiated by this particular NIAB box. You can select this, you can latch onto our uh, 5G NIAB. So you'll see all those network symbols, right? Now, of course, we do provide a utility if somebody is interested, because one of the usual lab use cases to actually validate the call flows. So we do provide the facility to capture some of these messages, which say educational institutions or other institutions, whoever may be interested, can then look into 5G call flows as well, right? So what you can see here is that the device has latched onto the 5G network, right? And of course, some of these 8K ultra videos, etc., you can watch on your device itself. We do provide a traffic analyzer option as well, through which the user can actually see the speed and other characteristics of the data that is being exchanged with the sensor or the device and the end network, right? So it gives a very holistic view to the application developer of the same. This was a short video uh, that described the whole setup. Right.
On our website, we have designed uh, a complete platform where you can go set up your own lab based on specific use cases. We have already predefined use cases as agriculture, education, healthcare, or productivity suite. So basically, you go there on a website, go to the link, and it will help you select the devices, the ecosystem of a 5G to complete your 5G lab setup. And then you can just connect with us after that, and we can help you out in terms of any more specific requirement you may have to deploy, test your 5G equipment, set up your lab, complete 5G ecosystem. So this in terms of 5G lab. So earlier we discussed that we have 5G lab ecosystem. We set up a 5G lab, but what about moving towards the actual deployment? That's where also Amantya has a product line. We do have a full-fledged 5G SA core, control plane, user plane both. And then an end-to-end 5G ecosystem, 5G solution, we call it as a Astra 5G. So we can have multiple RAN boxes connected to a 5G core and a UPF. So in terms of our core, which is both cloud native or can run on a bare metal, and then UPF is complete because we have already tested it over Mac. We can deploy it at the edge or alongside the core network, depending on specific use cases. We have already been working for deployment for Industry 4.0 use cases for enterprise private 5G network deployments. We fully supports comprehensive APIs for verticalized solution integration to third-party platforms. So from Amantya's portfolio, from a initial lab setup to an end-to-end private 5G network deployment, we help our customers fully.
Okay, so thanks, Gaurav Sharma and Gaurav Saini, for the wonderful demonstration. I see that there are a few questions already. So let's start it with the Q&A section. Here I have first question. This what spectrum band does it support? I think Gaurav Sharma can take this up.
Sure, Aakanksha. So one of the one of the again, one of the key aspects or a USP of the NIAB that we have. So there's a software design defined radio, which is part of this particular solution, which means that it gives you enough flexibility to actually configure different bands within the sub-6 spectrum, right? Now, typically, a lot of these bands that are currently, or the applications that are currently being tested, they are using band 77, 78, which is of course something already supported. Other bands as well within our lab, we use them for our internal testing purposes. So it's quite flexible in that sense.
Okay, great. So our next question is, to whom can I connect for having more details? Please suggest. Okay, so any queries regarding 5G lab or other offerings, you can send us an email on connect@amantyatech.com or visit our official website. Let's take this next question. How many users does it support? I think Gaurav Saini can take these questions from here.
Definitely, Aakanksha. So in terms of NIAP, because it's designed for lab environment pilot testings, uh, the network in a box can support from 8 simultaneous sessions up to 32. So we have different versions which can support up to 8 simultaneous session, or the another version of network in a box can go up to 32 simultaneous sessions. But we understand by our experience, what we are working with customers, uh, you can have up to 50 users provisioned, and then 8 simultaneous session in lab is good enough.
Okay, so the next question is, can this be used for private network deployment? Gaurav Saini, would you like to answer this?
In terms of private network deployments, uh, we propose our Astra 5G as a private network, enterprise private 5G network deployments because of the large ecosystem, large coverage footprint requirements. When we talk about network in a box, because it's SDR based, it radiates 10 dBm power, which gives a coverage up to 30-40 meters. From a lab perspective, it's great, but we from an enterprise grade deployment, we move to our Astra 5G.
Okay, thanks, Gaurav. Again, now, so we'll take one final question before wrapping up this section. So here is NIAB interoperable with third-party core network? I'll pass this question to Gaurav Sharma.
Okay, yeah, so that's an interesting question. Now, okay, so the NIAB product that we have, that again provides, or that's a USP of this particular product. You can integrate it to a third-party core, or the core can be running out of this particular box, or you can have the core running within this particular box itself, right? Now, the thing is that since our RAM solution is, and as well as the core solution is compliant to 3GPP standards, the interface between Gnode V and the 5G core network is something that conforms to release 16 at this point of time, right? So which means that any standard core or any third-party core that conforms to the 3GPP specifications, 15 or 16, should be interoperable with our NIAB, which means that there is this added flexibility to organizations wherein they can have these NIAB boxes connected to a single central core. So that's again one of the deployment scenarios that we offer. So that answers that, right?
Thanks, Gaurav.
Okay.
So I see another question from Mohit, who has asked that does it have an IMS as well? Yes, to the point. Last week itself, we have integrated or tested our VONR functionality on our 5G network in a box. So this support IMS as well, and we do support VONR on it.
Okay, so let me take this one of these questions. That's coming from Mohit, right? So how does an IoT sensor connect to your box? The box has 5G radio, so an IoT sensor should also have a 5G radio, right? So you're absolutely right, and that is where, as I mentioned earlier, the starter kit that we provide that comes into play. So the starter kit that we have, that consists of a few components, right? I'll not go into the hardware details of that. However, at a broader level, it consists of a 5G modem that actually talks on the radio interface. So that is one piece. The other piece is the application processor, wherein the actual application that the developer develops, it runs on that particular application processor. Now, we do provide the toolkit or the SDK through which the user application talks to the modem, uh, through which these messages then go in the uplink side. Now, the beauty of this whole particular the SDK or the toolkit is that the user isn't required to be a 5G expert, right? So you'll be having simple APIs like send MQTT message or send REST message, right? So this actually then is taken care by our internal SDKs that actually convert this into standard AT commands that typically the modem then understands, and that is how it goes onto the uplink side. So hopefully, and then the hardware kit. So some of these sensors we provide within our devices, right? So as you must have seen, the one that has camera and couple of more things. The hardware also provides extensibility, so it exposes USB ports as well, through which external sensors they can be connected to this. So we have a framework around which these sensors can easily be connected. Yeah.
Well, I can see there are many other questions on my screen, but we are very sorry we are running out of time. So let's connect via our official email ID for further queries. So that's all from today's session. I would like to thank each of the participants once again, and I look forward to more such frequent interactions. Thanks.